Today we're going to review absolute value. So first we're going to take a look at the equations. So the first one, find both solutions. Change this here. Okay, so first of all, if your absolute value is by itself, you want to split it up and find what will give you the positive and negative answer. And so we have 2x plus 5. That whole thing can be 11. And 2x plus 5, that whole thing can be negative 11. And then we're going to solve. So we're going to add 5 to each side of each equation first. Sorry, not add 5, we'll subtract 5. And we'll get 2x equals 6. And for the other one, we'll get 2x equals negative 16. And then the last step is we're going to divide by 2. And so we get two solutions here. X can be 3, and if you plug it in, we should get 11 on each side. And the other solution is negative 8. If we plug in a negative 8, we'll get negative 11 inside the absolute value, and that will equal 11 for the absolute value of negative 11. So two answers. Let's try the next one. This time we have numbers on the outside, and we have to get rid of those first before we split it up. So we have this multiply by 4, this plus 8. So first subtract 8 from each side. So we get 32 equals 4 times the absolute value of 2 minus 3x. We'll divide each side by 4. So we'll get 8 equals the absolute value of 2 minus 3x. Now we split it up into the plus and minus, and I'm going to do that over here. We'll have 2 minus 3x can be 8, and 2 minus 3x can be negative 8, and then we're going to solve. So subtract 2 from each side. We'll get negative 3x equals 6. We'll get negative 3x equals negative 10. And we'll divide by negative 3 here. And we get two answers. X can be negative 2, and this whole thing will work. And the other answer, x can be positive 10 over 3. So if we have a negative divided by a negative, that equals a positive. Okay, so that's solving an equation where we split it up and get two answers. The next thing that we looked at was absolute value inequalities, and we looked at two types, less than or greater than. And if it's less than, it's going to be between, so I'm going to write that right here. So if you have the absolute value by itself, you split it up, and we're going to get x can be 6, x can be negative 6, and our answer will be between those. So to write it up, we put our smallest number first. We put our x in the middle, our biggest number, to show that on a number line we start with negative 6, we go all the way up to 6. And this will be an open dot because there's no equal sign. And we're going to shade everything in between. So the absolute value of anything in between these two numbers will be less than 6. My workspace quit, so I'll start it again. The next one is greater than, and if it's greater than, your answer is going to be beyond your numbers, or bigger than your biggest and smaller than your smallest number. So again, if it's greater than, this is going to be beyond. Again, the absolute value is by itself, so split it up into two equations. 2x plus 5 equals 19, and negative 2x plus 5 equals negative 19. We're going to solve each equation. So first step, subtract 5 from each side. We'll get negative 2x equals 14, and we'll get negative 2x equals negative 24. And then we're going to divide everything by negative 2. And so we get two answers. X is negative 7, and we get x is 12. Oops, 14. Okay, so this is beyond, so it's going to be bigger than our biggest number. So to write bigger than our biggest number, x is greater than 12, or x is smaller than our smallest number, so less than negative 7. So here's what the solution looks like. On a number line, at negative 7, we'd have an open dot, and it's smaller than negative 7. And then here's 12, so greater than 12. Okay, so there's a look at absolute value inequalities. The last thing we're going to look at is word problems. So the first one, Trez gets $7.50 each month from his grandparents. The amount that he actually puts in the bank varies by $25. Write in it and solve an absolute value inequality that shows the range of money Trez puts in the bank each month. All right, so here's your absolute value of some amount minus $7.50. This is going to be less than or equal to this $25 right here. So the amount can vary, and we're trying to find the two ends that it varies between, so we use the less than or equal to. We're going to split it up. We got x minus 750 can be 25, and x minus 750 can be negative 25. We're going to add 750 to each side. And we'll get our answers, and a lot of you can do this in your head, but we're just showing the mathematical steps for getting this. So the highest amount that he can get in any given month would be $775, and the lowest amount he can be given or put in the bank any given month would be $725. And we know it's between these amounts, so here's our low end, $725, and we use a closed dot because of the equal sign, and we have our $775 as our high amount, and we're going to shade everything in between. Okay, so we say x is between 725 and 775. And here's what the inequality would look like. Low end less than or equal to middle x less than or equal to high end. Okay, let's take a look at two more. The number of pencils in Mrs. Bajan's drawer can be represented by the inequality p minus 7 is less than or equal to 3. How many pencils could be in Mrs. Bajan's drawer at any given time? All right, let's split this up. P minus 7 can be 3. P minus 7 can be negative 3. Let's add 7 to each side. And we get P equals 10. We get P equals 4. So the smallest amount can be 4. And we'll say less than or equal to x, which is less than or equal to the biggest amount is 10. On a number line, here's what it would look like. At 4, you'd put a closed dot. At 10, you'd put a closed dot, and you would shade everything in between. Last one. Last one. The temperature on Mars satisfies the inequality T minus 75 is less than or equal to 145, where T is the temperature in Fahrenheit. What is the range of temperatures on Mars? All right, so let's split this up. T minus 75 can be 145. T minus 75 can be negative 145. Let's solve. So add 75 to each side. So we get T equals, let's see, this is 0, 2. All right, so 220 is the highest amount. And then for the other one, we're going to add 75 again to each side. And we have negative 145 plus 75. And that can be negative 70. So the temperature ranges from negative 70, let me use a different color here. Let's use blue. Negative 70 is the lowest temperature, and the highest temperature is 220. And on a number line, here's what it looked like. It would look like at negative 70, closed dot, 220, closed dot, shade everything in between. So in class, we're going to practice reviewing, and we have our tests coming up, so we'll go over any questions in class.